Hi everyone, I'm Patrick and welcome to my talk how to create a great local Python dev environment with Docker. So let's have a quick look at what we talk about here. First, why Docker? And then we learn about all the steps that are necessary to have a great developer experience with Docker. So first we learn how we can Dockerize an app. So we start with the very basics. This is a very beginner-friendly talk. Then we learn how we can get immediate file changes from a container to our system and vice versa. So we talk about volumes here. Then we learn how we can set up an IDE inside a container. Then we learn about Docker Compose and how this will simplify everything. So then it only needs one command to start everything. And if we understand how Docker Compose works, we can very easily add more services. It only takes one more line, for example, to add a database then. So I also show you this in a quick demo later. And finally, we also learn how we can debug Python code inside a container. So yeah, I think these are all the codes necessary to set up an awesome environment. And now a few sentences about me. So my name is Patrick Loeber. I'm a developer advocate at Assembly AI. Assembly AI is a deep learning company that provides state-of-the-art AI models as an API. And here we use Docker for pretty much everything. So not only for deployment, but also for local development. So we're big fans of Docker. Also, I'm running my own YouTube channel. So you can find me with the handle @patloeber and the same on Twitter, patloeber. And then I'm also the founder of the Python Engineer website. So check that out as well for Python and ML tutorials. But now enough of me, so let's get started. And first, why Docker and why not just use a virtual environment? So Docker is much more than a virtual environment. It's basically a whole Linux operating system that is a isolated environment where you can then install all your dependencies. So not only the Python modules, but also all other dependencies on the system. And you can keep your own system clean and don't pollute this. Then you can very easily add multiple services. We will learn how to do this later. You can easily deploy this to the cloud then. Then your coworkers can have the same environment by spinning up the same containers. So also very cool to reuse the environment. And you can also quickly test out different Python versions. So for example, when the latest 3.11 came out in October, I used Docker to pull the latest image from the Docker Hub and then quickly spin this up and test this. So yeah, I think super cool to play around with different Python versions very quickly. And now before we start, I also want to mention that there is another Docker feature that is called Dev Environment. So this is currently in beta, I think, and this should come soon. So this is not what this talk is about. In this talk, we learn how we can set this up step by step together so that you learn all the Docker commands and the Docker features yourself so you understand what's going on. So yeah, I think this will be a cool feature that's coming soon as well. And also now, since we do this together, everything step by step, I also want to mention that all the code and the commands that I use, they will be available on GitHub. So you can find this here, GitHub Patrick Loeber Python Docker tutorial. This is the repository. But now let's get started with a demo app. And as a demo app, I want to use or create a small fast API web application. So for this, let's check out the documentation. And the first thing we would normally do is install the dependencies with here pip install fast API and pip install uvicorn. But in our case, I don't want to do this on my machine here. I want to do this in the Docker container later. So I want to save the requirements in a requirements.txt file. Here we put fast API and uvicorn. And now let's create the code. And for this, I recommend to create a new folder that I like to call source. And then in here, let's create our main.py file. And let's grab the example code from the website. So this is all that we need in order to run our first application. And now we want to Dockerize this. So for this, we have to create a file that is called Docker file in the base directory. And here, let me quickly copy all the commands and then let's go over them together. So this, and this. So first we start with a base image, and usually if you have a Python development environment, you often start with a Python base image. And then here you can specify different tags, and this is where you can very easily switch out the version. For example, here you can use 3.11, I want to use 3.10. And I also often like to use the slim version. This will just give you a much smaller version than the regular one, but it still works fine for development. And now the next thing I want to do is to create a working directory that I call code. This will now be the starting directory inside the container. So later you will see what this means. And now first let's copy the requirements file and then install this. And here we use -- no cache dir because Docker has its own cache, so we don't want this here. And then we copy the code, so the whole source directory, and then we specify the entry command. And it's good practice to have this separate because Docker can cache each step and the requirements don't change that often. So now if we have changes in our source code, then it can start building this from here, for example. And now to the entry command. So if we have a look at the documentation, then here in the terminal, we would say ubicorn main app -- reload. And here essentially we have the same, but here we need this as a list of strings. So we have ubicorn main app and -- reload. And be careful, since we are inside the source directory, here we also need to say source main -- app. And then here we are also already specifying the host and the port. So for the Docker, you usually always use 0000, and then you can access this from your local host as well on port 80. And this is all that we need in order to build our image. So now we can build our Docker image. And for this, we say Docker build -t, and then we give this a name, fast API image, and a dot for the current directory. And now this will build the image. So in my case, this was very fast because I did this before, so it was cached. If you do this the first time, it will take a few moments longer. But now we have this, so we can check Docker images, and here you should see your fast API image. So now the next thing is to run this, and we do this with Docker run, and then let's give this a name. One second, let me shorten this here a little bit. So this is the first command we want to use. Docker run -- name, then we call this fast API container. Then we want to map the port from 80 to 80, and then the image name is called fast API image. So now we run this, and now in the terminal you should see now this is starting. So this is using this starting command. And now since we mapped the port from 80 to 80, we can now access this on our local machine. So if we visit localhost port 80, we now see the app up and running, and here we get the response. So this is working. So now we Dockerized the image, but now let me show you one thing that I want to do differently here. So let's stop this again with Control-C. And let me actually also say Docker remove fast API container. Otherwise, I think it will complain. And now we use the same command again, Docker run. But here we also say -d, and this means it's in detached mode. So now, as you will see, it will immediately give me back the terminal. and it's also showing this ID here. So now this is running in the background on my machine, so I can still visit the localhost and test this. And also if we check Docker PS, then you see the container is still running. So let's quickly go to the localhost and refresh this, and it's still here. So now this is running on the background. So now we have, but now we have a few more problems, I would say. So first of all, if we go ahead and change something in the code, so let's return 1, 2, 3, 4. Then even though we say -- reload, if we go to our localhost and refresh this, we don't get the new code because this one here, the code is on my local machine, but the app is running inside the container. So the next thing we want to do is to have a mapping from our machine to the container that maps the code, so we can quickly make changes here and then it will affect the container. So for this, let's stop the fast API container, and also let me remove this again. And for this, we want to use a volume. So if we have a look at the Docker documentation, volumes are the preferred mechanism for persisting data. So in order to use this, we can do this with an additional command. So, or with the same command, but an additional parameter. So here we say docker run. And now in the end we say, or somewhere in here, you say -v for volume. And then we want to map a location from our machine to the location inside the container. So I use $ and then pvd. This is the current working directory. And I want to map this to /code. So this is what we are using here. And if we, for example, open a new console and type pvd, then you see this will give me the current working directory where the code here lives. So now if we run this again, and now we have this as a volume, then now it's starting this again in the background. And now we can visit our server again. So let's refresh this. Here we have hello world 1, 2, 3, 4. And now if we go into the code and make a change, so let's say hello world ! And save this. And now if we refresh this, then now here this is updated immediately. So this makes our life much easier when we develop here. But now we have another different problem. So we still can't really code in here because my IDE is already complaining about fast API. For example, if we want to go to the definition, then it says no definition found for fast API. So we don't get auto-completion and all the good stuff. And this is because my system, my IDE here doesn't know about fast API because I didn't install this here. I only install this inside the container. So what we actually want is to have this IDE inside the container. And don't worry, this is not too difficult to set up. You can do this with both VS Code and PyCharm very easily. In my case, I use VS Code. And for this, we want two extensions. The first one is the Docker extension, this one. And the second one is called dev containers. So install them. And then in the lower left, here you should see this little button here. And then there are different ways how you can connect to a container. For example, we can attach to a running container, or we can open a new folder in a container if we have a Docker file in this container. In our case, since we have our container running, so it's still running in the background, we can attach to a running container, and then we select this one, the fast API container. And now this opens a whole new instance of VS Code. And this lives now inside the container, or basically it's just connected remotely, but yeah, it's living inside the container. And here, as you see, it's no longer complaining about fast API. So here it should know about this, but we still, for example, if we do a right click, we don't get all the other suggestions like go to the definition. And this is because this is a whole new environment. So here we again have to install the Python extension first. And don't worry, you only have to do this the first time. So here, let's install this in the container, and this might take a few moments. So, oh no, there's already here, perfect. So now we have this, and now if we go to this, and then we can go to the fast API definition, and then jump around in the code, and also we should get auto completions. So yeah, perfect. So now we can develop inside the container, and also remember, since we did the mapping with the volume, also this works the other way around. So for example, if we do some changes in here, and then let's go back and refresh this, then we also see this here. Perfect. So now we can code in here and implement our app, and we get all the support from the IDE that we are used to from our machine. We even can customize this even more with other extensions or install other dependencies and make this a completely new isolated coding environment that has the Python 3.10 installed here that we specified here, so you can easily switch this out. We also immediately see the changes and can test this, and we also don't lose the changes. So since we used the volume, we now immediately have this on our system as well and can then push this to GitHub. Then, for example, if we start a new terminal, you will see that this will be inside the container now, and it is inside the code folder. So this is the working directory that we specified here. For example, if we cd one level up and list everything, then you see all your Linux folders here and also the code folder. So let's cd into code again. So this is why we specified this here as a work dir. And here, if we see the requirements and the source. So this is what we copy here. And since we are using a volume that maps everything right now, we also see those two files. And yeah, so this is now how we can set up an IDE inside a container. And now I want to talk about Docker Compose. So let me stop everything. So let's close the remote connection and this instance, and here we are in the old one. So as you have seen, we used this very long command with the -p, with the -d, with the -v, everything. So now we can simplify everything with Docker Compose. So let's have a quick look at the documentation. So Compose is a tool for defining and running multi-container Docker applications. So here we define one YAML file, and in there we can configure all the services and, for example, then also define the ports and the volumes and other stuff. And then we only need one command to start and stop everything, and we can easily add more services. So let's do this. Let's actually stop this again. So we no longer want this. So we stop the fast API container, and let me also remove this and have a quick look. So now we no longer have any containers running. And now instead of the Docker file, or rather in addition, we also want a Docker compose.yaml file. And here, let me also copy this from the README, and then we go over this together. So first, let's use only this. And here we specify all the services that we want. So for now, we only have one that we call app. Then we specify that we want to build from the local Docker file. Here we can also say image and then specify an image name from the Docker Hub. And you will see how to do this in a few moments. For now, let's keep the build. Then we give this a container name, and then we give this a command. And essentially this is the same command that we are seeing here, but now written in the terminal style again. And then here we have the configuration for the ports and for the volumes. And essentially this is the same configuration that we see here in this long command with this -p and the -v. So this is just a different way to configure this. And now instead of this whole command here, we only need to say docker compose up. And now this will start all the services here. So now as you can see, it's running again. So we can visit our localhost port 80. And here we have this. And we can also make changes. And then we should immediately see this. So in the terminal, you see we have some more infos. And if we refresh the page, then we immediately see this. So this is working. And now let me stop this again. And in order to shut everything down correctly, we want to say docker compose down. And now I want to show you how we can add more services very easily in here just by adding a few more lines. So in this example, let's add Redis, for example, as a database or as a cache. So we define a new service name, and now instead of the build command, here we say image and then a image name that we can find on the Docker Hub. So let's search for Redis Docker Hub, and then we should immediately find this. And here you also see the available tags. So I want to use Redis Alpine. So let's copy this in here. And now for our first service, we want to say this depends on the Redis service. And this is all that we need in order to add multiple services to the Docker Compose. And here, of course, we can also then specify more configuration. But this is all that we need in order to get this. And now this will pull Redis from the Docker Hub and then also install this inside the container. Then we don't have to install this on our machine. And now before we restart everything, let me also add Redis as a Python dependency. So this is the Redis Python module. And now we can use this in the code. And now we want to say docker compose up again, and this time let's also say -- build because we changed something in here and we want to rebuild our image. So let's say -- build, and then let's also say -d. So now it will again be in detached mode. So let's run this. And the build is done. So now, for example, if we say docker ps, then we should see the Python server and also our Redis image. So these are now both running in the background. And now we can, for example, add Redis here to our code. So for this, let's also attach this again. So let's say attach to running container. Then we want our Python server. And now it's restarting the VS Code. And now I think this will be again a different one. So I think we again have to configure Python, the Python extension here. Don't worry, you only have to do this once and then it will always be there. But since we used the Docker Compose file now for the first time, this is building a separate image and a separate container now. So, but now we have this and now we can use this. So we should be able to say import Redis and it should be there with auto completion. So I think Python is still installing. So let's wait until this is installed. And now installation is done. So let's try this again. Import Redis, and now you see we have the auto completion, so it finds Redis. So now let's quickly add this here. So for this we say r equals redis.redis, and then as a host we say host equals, and this is our service name, which is also called Redis. And then for the port we use the default port, which is 6379. And now let's, for example, define another endpoints where we say hits, and then here we can say r.increment, and let's give this a key. So let's call this hits, and now here we want to return hello r.get, and then we say hits, and here we say the number of hits, and now this should be working. So everything is already synchronized. So let's refresh this and let's go to /hits, and here we see the number of hits 1, and if we refresh this then we get 2, and let's refresh this again, 3. So our Redis service is working, and this is how we can easily add more services to the Docker Compose with just a few lines of code, and everything is still synchronized with the one Docker Compose up command. So yeah, I think this is a super cool feature. And now the last thing I want to show you is how we can debug the code inside our container. So if you go in here and, for example, set a breakpoint here, then we want to be able to start the debugging here. So for this, let's first close this again and also close this instance. So for this, first we need to add one more package to the requirements txt, and this is called debug.py. And then we also need to add the port of debug.py to this port. So it's 5678, and we map this to 5678. And now we can again say docker compose up --build -d and run this in detached mode. So now this is building again, and now we have the debug.py package then. So let's again connect this to the running container. And now this time we should be able to have our Python extension again. And now we should be able to, for example, go to the definition. So yeah, our Python extension is working. And now in order to debug this, we need to add a small code snippet. So we say import debug.py and then debug.py. And you see it's already recognizing this. And then we say listen. And then here we use a tuple. And the endpoint will be at 0000. And the port is 5678. So this is what we specified here. And now we could also say debug.py wait for client, and then it's blocking here until we connect. But here we can let this run through, and now when we hit the endpoint, then it should trigger this breakpoint here. So now this is all the code snippet we need. And now we can attach the debugger. So let's start run and debug. Then let's say create a launch JSON config. And here we can select remote attach to a remote debug server. This is now where we are running, so we can leave the local host since we mapped this. And also the default port is 5678. So let's hit again enter. And now we created our configuration. So now our debugger is running, and now if we go to the endpoint /hits, then we should end in the debugger. But first, of course, we have to also start debugging. So let's start this again and let's hit the endpoint again. And now we are inside the debugger and it's stopped here. So now we can inspect all the variables and have our debugging up and running. And then, of course, we can step over this and then, just like with a normal debugger, do some more sophisticated debugging. The other option that I didn't mention, I forgot to mention, of course, we can always go to our container and then have a look at the logs and then do, for example, some debugging with print statements. So for this, have a look at the container that you find in the Docker GUI. But this one is a little bit more advanced, and it's also not too hard to set this up. So yeah, these were all the things I wanted to show you in this talk. I hope you enjoyed this and could follow me here. If you have any questions, drop them in the comments or feel free to reach out on Twitter. Also check out my YouTube channel. And yeah, thanks for watching, and then maybe I see you next time. Bye.